Yeah. So now we are at rise time characteristics. So rise time is defined as it is the time required for the anode current to rise from 10 percentage to 90 percentage of its final value, and at the same time we can also define it as it is the time required for the anode voltage to fall from 90% to 10% of its initial value, right? So this is what the rise time. And next one, another more time period is what spread time, ts, and it is the time required, it can be defined as it is the time required for the anode current to rise from 90 percentage to the 100 percentage, that is the final value, and at the same time it is the time required for the anode voltage to fall from 10 percentage to the forward conducting voltage, that is I can consider this voltage as 1.1 to 1.5 volt, right? 1 to 1.5 volt, right? So this is what, so completely what I can consider, this turn on time T on, this turn on time T on is a combination of summation of TD plus TR plus T spread. So these are the three things we have to remember, right? So this is all about the turn on characteristics. Now we will be switching on to turn off characteristics. How we are going to draw the turn off characteristics? Let us draw, right? So once SCR is turned on, there will be charge carriers present at all the three junctions. I have deleted the diagram over here. You please refer the diagram, right? So to turn off the SCR, we need to remove the complete charge carriers across those three junctions, right? So the time required to remove the charge carriers from the junctions J1 and J3 is called reverse recovery time, TRR, and the time required to remove that the charge carriers to remove the time required to remove the charge carriers from junction J2 is called as gate recovery time, TGR, right? So reverse recovery time and gate recovery time. Reverse recovery time is the time required to remove the charge carriers from the junctions J1 and J3, and gate recovery time is the time required to remove the charge carriers charge carriers from the junctions J2, right? J2, right? So now, so this turn off time is a combination of summation of T reverse recovery time and gate recovery time, right? So now, so to turn off the SCR, what you have to consider? To turn off the SCR, we need to decrease the anode current below the holding current, right? Below the holding current. So what is so for this, what I am going to consider, this anode current, the anode current decreases with a rate of di by dt and reaches to a maximum value here, and then increases and then increase to reach the steady state. This is what the steady state, and finally attains what, zero value, right? So it reaches, why it reaches this maximum, negative maximum? It reaches this negative maximum because of the presence of charge carriers at the junctions J1, J2 and J3. So due to the presence of charge carriers, the anode current will not reach as zero at this particular condition. It will reach negative, and then it will attain some kind of a steady state, and finally it reaches zero, right? So now, as the anode current reaches negative maximum, the anode voltage has a spike. See, if you clearly see this, the anode voltage has a spike, and after the removal of charge carriers at junctions J1 and J3, so it reaches to zero as shown in the figure. This is what reaches to zero as shown in the figure. So the SCR is off. Now the SCR is in off position, but there are some charge carriers present at the particular junction J2, and in order to make the SCR completely off, what we have to consider, we have to remove the charge carriers present at the junction J2, and the time required for the removing the charge carriers at the junction J2 is called as what, gate recovery time, right? Gate recovery time. So the time required for anode current reaches to zero voltage, right? The anode current reaches to zero voltage is called what, circuit turn off time. It is represented as TC. So in turn off characteristics, we have come across three important terminologies, three important time periods. One is reverse recovery time, and second one is gate recovery time, and third one is what, circuit turn off time. That is the time required for the anode current reaches to zero to anode voltage reaches to zero is called what? Circuit turn off time. Anode current is reaching zero here and anode voltage is reaching zero here. So the time required for anode from anode current reaches to zero and the anode voltage reaches to zero is called what? Circuit turn off time. So this is about the switching characteristics of SCR. We can say these switching characteristics also called as dynamic characteristics, and it always deals with turn on and turn off time periods, right? Turn on and turn off time periods, right? Yes.